There we go. The first script that I'm going to be trying is the photometric color calibration, and in processes you can find that by going to process, all process, and just scroll on down. And here you go, photometric color calibration. Now I saved this and my settings as a here it is, and my settings, and these same settings I would encourage you to use as well unless you find you need to go elsewhere. There's a lot here, and the first thing you're going to need to do is to download two catalogs, the GAIA capital D, capital R, capital 2. I'm spelling those. I'm not sure how that shows up on the internet. It's kind of grayed out. And then this one is the capital A, capital P, capital A, capital SS, all caps, APAS. Now, to find these, you can go to the PixInsight forums, and there is a with regard to Juan Canajero, who's one of the main cogs in PixInsight, and if you Google APAS and get Gaia processes, he'll show you where the links are to these programs. But essentially, one of these plate solves, APAS, I think, stands for Access to Photometric All Sky Survey, and I don't know what Gaia stands for, but the Gaia process, first your image is plate solved, and then they compare the color and adjust the color based on information coming from reality. There's a website on APAS. It's aavso.org /APAS, and it will explain how the all sky photometric survey works, and fundamentally what it's designed to do. So it's made for astronomers, and PixInsight has tapped into it. So you need to have those two programs downloaded in order for this program to work. And then what you'll do is, we'll bring up my image. What you'll do is you'll plate solve this image. You're going to search coordinates, and I would type in IC 1318, and it will find it. It's using the CDC Strasbourg, France server, and so it's searching for it. Running into an issue. It's all froze up on me. Let's try it again. Search. Wonder if my internet's working. Let's try something else. Cancel. Search. Now it did it. I was on the guest internet, and I have limited access to the internet. We have grandkids. Okay, so it's solved, and I just go fetch, and it's put in the coordinates. I have to put in the focal length of my telescope, which is 336 millimeters, and the pixel size, which is 3.4. But if you remember, I drizzled 2 times, which means that I need to double this, and so I'm just going to put 700 millimeters. It's going to tap into these two resources, and it's going to take it a few minutes, and then it's going to solve it. So I'm going to click on apply, and it will color calibrate. It's going through its gyrations down here. Okay, it's completed the process, and it brings up this graph. Don't ask me. Adam Block does a good job of explaining it, but I failed to understand it. This is our color calibrated image. We'll stretch it. And there she goes. And best of my understanding, by the way, let me open up this box so you can see all of them opened. And one more thing too, while I'm on this box, if your camera saves all of the metadata, then you don't have to use the search coordinates and type in your target. You can just click on acquire from image, and it'll bring in the focal length, the pixel size. You'll still have to adjust the focal length because your metadata, that is if you drizzled. If you didn't drizzle, then use the actual focal length of your camera. But if you did a 2x drizzle, then you want to double your focal length. If you do a 3x, you want to triple, because your star size has changed. And this is comparing your stars and the color of your stars with their actual color coming from these catalogs, and it adjusts your stars to what it should be. Wonder why I'm continuously drinking. Hot coffee kind of solves the dripping problem that I have. But at any rate, apologize for the continuous coughing and clearing my throat. So you'll need to download these two catalogs, and these settings will work for you. I wouldn't change anything else. I haven't changed them yet, and these are the settings I borrowed from Adam Block. Thank you again, Adam. So this is one method to color calibrate. This takes longer. This process right here will run a minute or a little more in some cases, and so just beware of it. I'm going to close this one out. And also, what I should have done is made a couple other instances. I'm going to move this one over. I'm going to bring this image back. This was before background extraction, and I'm going to make a copy of it. I'm going to put that back, and then very quickly I'm going to run background extraction. Actually, I don't want to run it on this. I want to run it on that. And here are our, I want to run it in division as we did last time. And we'll stretch and close. We're going to run it again. This time we're going to run it in subtraction, and we're going to stretch. We're going to apply it. So essentially, this is the same image as this is this image over here looked like this image before we applied the colorimetric color correction to it. Now I want to make another copy of this, and we'll minimize this one, and we're going to call this color calibration auto color. And we're going to call this just color calibration. And this is with Photometric, so we'll remember, and all I'm using now really is Photometric color calibration. So what I want to do, I'm going to return that there. What I want to do is bring up color calibration, and I'm going to create two preview boxes. I'm going to uncheck star detection. I'm going to zoom, and I'm going to look for an area of the sky that's reasonably background and no stars, just a small area. And then I'm going to look for a star that appears white, it's not oversaturated. That might be hard to do. Let's try this one here. Let's zoom up a little more. I lost it. Yep. Let's go back down here. Gotta find another. Okay, this will work here, I think. Okay, it's not oversaturated, so let's make a preview out of that, and then we can I'm not using star detection. If there's a couple of ways, there's several ways you can run this color calibration. This is the way I prefer. But I'm going to use my reference image, and my white reference is preview 2, and my background reference is preview 1, and that's all I'm doing. I'm going to apply that to this, and it is color corrected. So far we have used two methods of color correcting, and are they different? So this one seems to have pulled out more nebulosity. It just added some contrast that this one didn't add. So this is the color calibration. This is auto color. Now, in order to run auto color, you're going to have to download a script, and you go to your scripts, and under utilities, utilities, actually auto color looks like it's been removed. Well, that's good, because then I'll reload it and show you how. I guess with the last update it removed it. Okay, well, we're going to reload auto color as a script. You can find auto color by going to this website at skypixels.at, PixInsight scripts. Hartmut Bornemann created this particular script, and just go down here to this list of scripts, and there should be, here's auto color, and when you get to here it is. Here's auto color, the zip file, and download and install that. And here's how you install it. Let me go back to PixInsight. When you saved it to a directory, then go to scripts, and go down to Feature Scripts, and you're going to click on Add, and I'm going to go to Hartman-Borman Scripts, Autocolor, and I'm going to click on Open. One additional script was found. It installed it. I clicked on Regenerate. I'll close this and go to Scripts, Autocolor, and I am now running it. All you do is click on it and it runs. It takes a second too. Okay, it is finished, and this is a lot different. In some ways, I'm really liking this particular color calibration. Here is the color calibration as ran by this program here, color calibration, without using structure detection, and then this is color calibration using the Photometric, which is probably where I'll end up staying. Yeah, these are a lot more alike. Photometric though has no, I tell you what, I'm not sure. I may process them both, and ultimately I may lean more towards the Hartman-Borman method. But I do want to show you one other way of doing this, and in order to do that I need to create another instance of this. So we're going to put that. These are 3 different autocolor methods, and actually what I'm going to do is I'm going to go up to autocolor, make a clone, and then I'm going to go here and back it up to before it was colored. And the only reason why I'm doing this is I wanted to show you the difference between the original and this. I want to go back here though and unstretch and stretch. Okay, that's where we were. This is after we ran autocolor with Hartman-Borman. I want to show you one other thing that you can do, and let's put this one up here, and let's bring back up color calibration, and we're going to create another background preview, and right here's fine. And this time we're not going to use a star that hasn't been saturated. Instead we're going to keep structure detection, and so we're going to find our background reference, which is preview 1, autocolor preview 1, and we're not going to put anything for our reference image. We're going to use all of the structures in this image, primarily the stars, they're going to detect those and calibrate against all of the stars. So we'll get another variation of color calibration using structure detection. Structure detection probably is more useful when you have a lot of stars and nebulosity in your image. So we calibrated using structure detection, and here is using the same tool but just picking on a star, and I actually don't see that big of a difference. Yes, I do. This has more yellow in it than this one does, but the stars now are no longer in that magenta mode. We're just seeing the dominance of the green channel because of the hydrogen alpha dominance in the image. So really a lot of good contrast in here, and one of the reasons why the Hubble palette was such an important combination of color mapping using the SHO mapping feature was that it gave contrast to the image that otherwise wasn't there. But there's a lot of contrast you can see, and even more can be brought out. It's just not as cosmetically accepted when it's all green. It is to me, but it isn't to the Astrobin Society. Okay, well, I'm going to probably stay with my colorimetrics. I've decided to stay with my colorimetrics, so that's this one. I'm going to go ahead and delete autocolor and click to no, and color calibration, and I'm going to keep autocolor, and I need to rename this underscore photometric color calibration. I'm going to make a copy of that and put that back where it was. So far we ran a linear fit, we cropped, we ran background dynamic background extraction, and now we've ran photometric color calibration. And when we go to part 9, we're going to run the multilinear transform, and we're going to add some noise reduction to the background and to some of the nebulosity, but hopefully not to the area of nebulosity where we have some nice detail. And then we're going to be extracting a luminance layer from this and running deconvolution on the luminance layer. You always run your deconvolution on your unstretched image, on your linear image. So we'll be running the deconvolution feature. That will be in part 10. So join me back here for part 9, and we will run the multilinear transform tool. Have a good rest of the day. Catch you later.